Hi viewers! In this video, we're going to discuss the topic Django models. Following this, we'll look at the Django ORM, Object Relational Mapper, and then how we can use this Django ORM to connect and interact with our database. After that, we'll see how to create our own Django model and post data into it using Django. Finally, we'll look at the database relationships within Django models.
What is a Django model? First, let's see what a Django model is. A model in Django is the method we use to create a table in a database in a simplified way through a Python program. That is, we can completely define the database table schema through a Python class. How does it work? Each column in a database table can be defined through attributes in a Python class. That is, we can define all the table schema definitions like the column name, data type, and constraints using Python attributes. For example, let's take an e-commerce website, because we'll be building one throughout this series. To hold the products in the e-commerce website, we need a product table. To create this, we can create a Django model called product. We can create fields, which are also called attributes, like name, price, and stock. Once we execute the migration command, Django will automatically create this table in the database for us. Django models can only be created using Python classes. They cannot be created using Python functions.
Next, what is ORM? ORM stands for Object Relational Mapper. Django provides its own built-in ORM. We can use this ORM to interact with the database using Python code. For this, we don't need to write any SQL code. Django itself will write the SQL. In legacy web development, they used raw SQL to interact with the database. But in modern web development, ORM is mostly used for database interaction. Okay, let's look at an example for this. In the legacy way, raw SQL to fetch data from a database would look like this. Select star from table name where condition, such as price greater than 1,000. However, in modern web development, using the ORM, it would look like this: product.objects.filter price_GTE equals 1,000, greater than or equal to. There are several advantages to using the Django ORM. First, it is very easy to write and understand. Second, it results in much cleaner and more concise code compared to verbose SQL. Finally, it is safer and more secure by design, as it helps mitigate risks like SQL injection attacks, which is a common attack on all websites. Next, let's create the product Django model needed for our e-commerce website. Before that, let's look at the database settings. Open settings.py. If you scroll down, you will find a databases setting below templates. It uses the SQLite 3 engine. This file will be created in the base directory as db.sqlite3. It is created right under our project's root folder. To visualize the structure clearly, I will minimize the app folder and the main project folder. This SQLite3 is a database used for development purposes. It acts like a file, so it's easy to place in our project and use. When we move to production, we can use databases like PostGRE or MySQL. In the future, if you want to move data from SQLite to a production database, Django provides built-in facilities like data migration commands for that. Now I'll open this file. When you open it, it will look like this. There is no table, just an empty database file. Note, when you try to open it, it might not open. This is because you need to install an extension. Click the Extensions icon and search for SQLite. Install the SQLite Viewer extension. After installation,
I will now return to the folder Explorer.
when you click db.sqlite3, it will open.
And now you can see all the tables within this SQLite database file.
If this file is not created for you, you can either run the server command or execute the migration command, and the database file will be created. Currently, there is an empty database file. Django provides some predefined tables for different purposes, so let's create them. Navigate to the project's root folder in the command prompt. I have already activated the virtual environment. Type Python manage.py migrate and press Enter.
After pressing Enter, you'll see several migration commands execute. This means the default Django tables have been created.
We can't see any tables yet, so
We'll refresh the database viewer. Now all the tables have been created. Next, let's create the product Django model for our e-commerce website. Expand the Products folder. I have created a video previously on setting up the project and app folders, so watch that. Click on the models.py file in the Products folder. As we saw earlier, we can only use a class for Django models. Create your models here. Class, Product.
Inside this class, we need to inherit from Django's models.model class.
we are closing the class header with a colon. Inside this class, we will define the product table's columns as class attributes. We will define the following attributes: name, to store the product's name; price, to store the product's price; description, to store all information about the product; stock, to track the number of products available. The next step is to define the data types such as integer, string, and float, along with constraints like max length, null, and default. For each of these, we will assign the appropriate Django model fields.
Models.car field with max length 200.
The max length equals 200 constraint ensures the product name cannot exceed 200 characters in the database.
Price, models.decimal field.
For the product price, which requires decimal precision, we use decimal field.
With max digits 10,
and since price won't exceed 10 digits in most cases, we can set max digits equal to 10.
Decimal places 2. Description, models.text field.
A text field is ideal for the product description, as it can hold large amounts of text. I will leave it without a max length constraint.
We also set blank equals true, allowing this field to be empty.
Finally, we will use an integer field for the stock to track product availability. Stock equals models.integer field default equals 0. The default equals 0 value ensures the stock is automatically set to 0 when no product is available. We have now completed the product model fields. In addition, we are going to create a dunder method, a special Python method for this class. We can say like display method
__str___ to define what text should be displayed for each record in the table. I'm returning self.name.
You can construct the str method as you like. For example, you could return self.name plus, comma, plus str of self.price. However, I will keep it simple and just return self.name.
Now we have successfully created a Django model. To create this model as a table in the database, we need to run the migration command again. Since this is a custom model, we first need to create the schema. For this, we use the make migrations command. We didn't run this for the default tables because it's already included in the Django package.
The make migrations command creates a migration file with the instructions for the new table. In the command prompt, type python space manage.py space make migrations. This creates a migration file. It shows the file name. This file is created inside the migrations folder. If you open it, you will see the definition for creating a table. The migrate command then applies these instructions to the database. This is not essential to read. But the table is not yet created. Now we run the migrate command, python space manage.py space migrate.
It shows applying products, OK. This means the table is created. We'll check the database. Now we see the products_product table. Currently, there is no data. Next, let's see how to post data to the table. We can post data in two ways, using the Django Shell or the Django admin panel. The admin panel is more convenient, but in this video, we'll use the shell. We'll discuss the admin panel in the next video.
We can use the Django Shell to post data by leveraging the Django ORM to create and save model instances.
To open the shell, type python space manage.py space shell. Now we have opened the built-in shell. First, we need to import the model from products.models import product. Press Enter to execute the statement we have typed in the shell. If there is no error, the statement is correct. Next, we create a product object. P equals product, in parentheses, name equals laptop, comma, price equals 75,000, comma, description equals gaming laptop, comma, stock equals 10.
To confirm the fields you've entered in the shell, you can check the relevant models.py file. If you make a mistake in the field name, like I did with description, it will throw an error, so correct it. Copy the product object we just created above and paste it below. Update the description field to include the missing P. Press Enter. No error means the data is safe. Now we save the data to the table. p.save. The data is stored. We'll refresh the database viewer. The data is stored. Retrieving and updating data. Now let's see how to retrieve data from the table. Product.objects.all. This returns a query set with the laptop object. Next, how to filter the data and retrieve it. Product.objects.filter price__GTE equals 50,000. This retrieves the laptop record.
Because we have only one record with a price greater than 50,000.
Next, how to get a particular record. Product.objects.get ID equals 1. The ID is implicitly created and available in the database. This gives us the laptop product. This is also returned as a query set. Now, how to update the data. Let's update the stock from 10 to 8. P.stock equals 8. You must explicitly save the object to update the database. P.save.
I have not pressed Enter yet. In the database viewer, you can see the current stock is 10. Now I will hit Enter to update it.
We refresh the database viewer. The stock is updated. We'll check the data. It is now 8. Finally, how to delete a record. P.delete. I will not execute this command now. This is how we use the shell to update and make changes to the data. This approach is not recommended for routine data management. However, we will use this same code logic in our views to interact with the database. I'll exit the shell. Next, let's look at Django Model relationships. Django Model relationships are classified into 3 types: one-to-one relationship, many-to-one relationship, and many-to-many relationship. We'll look at an overview of these relationships. We can post practical demonstrations in future videos if you mention it in the comments. One-to-one relationship. To explain the one-to-one relationship, I'll take the real-time example of person details and their passport details. On the left, we have person details, 3 users. On the right, we have passport details for those 3 users. The last column is the one that links the person table and the passport table. First user, John, holds passport ID 101.
US passport. Second user, Andrew, holds a Canada passport. Third user, Aiden, holds a UK passport. The linking is straightforward. Now, the Django model code.
Fields for first name, last name, date of birth, etc. Passport model, fields for passport number, country, issue date, expiry date, etc. The linking field is person equals models dot one-to-one field, person, on delete equals models dot cascade, primary key equals true. Models dot one-to-one field, person, links the passport model to the person model. On delete equals models dot cascade. If the person record is deleted, the corresponding passport details will also be automatically deleted. Primary key equals true uses the person table's primary key as the primary key for the passport table.
2. Many-to-one relationship. The real-time example for many-to-one is e-commerce customers and their orders. Customer table on the left, orders table on the right. The customer ID foreign key column on the right side links the two tables.
This is a many-to-one relationship because one user can be associated with many orders.
The first customer has placed 3 orders. The second customer has placed 1 order. The third customer has placed 1 order. Django model code. Customer model. Fields for first name, last name, and email. Order model. Fields for order date and total amount. Here, we can add as many fields as needed to the order model. The linking field is customer equals models dot foreign key customer on delete equals models dot cascade related underscore name equals orders. Models dot foreign key customer links the order model to the customer model. On delete equals models dot cascade. If the customer record is deleted, their order details will also be deleted. Alternatively, you can use on delete equals models dot set null if you want to keep the order details for future reference. Related underscore name equals orders allows easy referencing of the related orders in the code. 3. Many-to-many relationship. The real-time example for many-to-many is author details and book details. Author table on the left, books table on the right. To link them, we need a junction table in the center, which Django will create automatically. Without this junction table, we cannot create a many-to-many relationship. Author 1 has written book 101 and book 102. Author 2 has written book 101, along with author 1. Author 3 has written book 103. In this scenario, one book can have multiple authors. One author can have multiple books. This is why we use the many-to-many relationship. Django model code. Author model, field for name. Book model, field for title. The linking field is authors equals models.many-to-many field author. Models.many-to-many field links the book model to the author model. We cannot use onDelete equals models.cascade here. If we delete an author, the book they co-authored should not be deleted, as other authors might have written it. Conversely, if a book is deleted, the authors should not be deleted, as they might have written other books. This linking field, authors, is placed in the book model here, but it could also be placed in the author model. Keep in mind that the book model will be passed as the argument instead of the author model. Books equals models.many-to-many field book, where it would be a vice versa specification. This is how we use Django model relationships. This allows us to build complex, data-driven applications. If you like this video, please like, share, and comment, and subscribe to my channel. Thank you for watching this video.